Hello people, this is video 24 for the motion design application 3D experience, which is closely related to video 23 actually. I'm solving the same problem, but here I will use 3D contact to model the problem. So we have a small cylinder that's rolling inside of a bigger cylinder, as you can see here. And I will not be using the roll curve joint that was done in 23. I will just release this thing, assuming that it's all the way on the top, release it, and see what happens. And the only thing that's basically holding, the only thing that's interacting between these two is the 3D contact. Now, just to remind you that this was done in 23 with roll curve joint, which is essentially a different problem. Okay, so I'm going to initially assume that the interaction is frictionless. There's no friction between two surfaces, and then I'm going to introduce a friction coefficient, and you see that there's a big difference between all these three cases, video 23 and what you see here with or without friction. Okay, so let's go ahead here and we're going to start with an assembly design. I will insert my outer cylinder. So let me insert the 3D part. And I'm going to call this thing properties, outer cylinder. Copy, paste. I'm going to make this thing yellow. Let's go to part design and make it. So on that vertical plane, I will sketch. Why don't I use an arc? So centered here, there. I'm going to give this thing a dimension, 1 meter. Okay, view fit, there we are. And I'll do the rest of it. So back to sketch, another arc, same center, starting here, going there, and exit. Oh, let me finish these borders. Another one. Okay, exit. Yeah, exit and pad it. I'll make it point 0.5. There we are. Now, that's pretty much it. So go all the way in the top, insert your 3D part. This is going to be the rolling cylinder. Properties. Rolling cylinder. Copy this. Paste. I'll make this thing orange. Okay, let's go make it. So double click on 3D part, go into part design. And what I will do is on this face, on this face, I will sketch my other circle, which is the inside cylinder. Let me make this thing 0.1. And then the dimension from here to that is going to be, try it again. Here to there is going to be 0.9 to make it tangent. Okay, that's pretty much it. Exit and pad this thing. See which direction did it pad? Okay, I'll make this thing a point, I don't know, 0.2. There we are. Okay. Now, We go all the way to the top. Let's fix this outer cylinder, or so let's fix this outer cylinder. Did I do that? Good. And uh, because there are no joints, I'm not going to be using any joints. I'll just leave everything else the way it is. In 23, I created joints here, but not in this tutorial 24, which involves contact. So now we're going to go to motion design. Immediately, mechanism will be created, but there are no joints. You can see that there are no joints. The only thing is the fixed part, fixed cylinder. That's all. Gravity is applied. 9.81 is over there. And that's pretty much it. So the only thing that I have to do is to create contact between this outer cylinder and inner cylinder. So I go to the mechanism, and here is 3D contact. It says, what are the things that are contacting each other? Well, there is the outer cylinder, and then there is the inner cylinder. And if you go scroll down here, open the contact properties, I want to make it frictionless first. In other words, let's see what happens when we make it frictionless. 0. And this is over a 5-second period. So let's see now. 5 seconds default. That's fine. Let's go run it. See what happens. I don't want these planes. Let me hide these planes. Same thing down here. These planes I'm going to hide. Okay, good. Now we go to simulation and run it. Run case. It's running. Once it says succeeded, we can go and plot stuff. Succeeded. So I'm going to select the results, which is this. Go to results tab, animation, and let's see what happens. Let me first play it. Okay. So let me bring it back. Okay. See what happens. This is what happens. No friction. Now, of course, this behavior is because of numerical computation. Because if everything was numerical computation, but notice that what happens if this thing was not close to the edge, it will behave differently. Okay, the behavior depends on how much of this is hanging over that too. So what I'm going to do is actually to convince you, I'll go to this, make this thing longer, maybe 1 meter, and let's go and run it again. So we go back to scenario, and simulation, and run it. Okay, succeeded. Select this, go to results, animation, and play it. Turn it around. Okay. So let's go ahead and add friction. So we go to 3D contact, add a friction coefficient of maybe 0.1, see what happens. This is what we have originally. It goes like this. And now we're going to simulation, run analysis, wait until this finishes. Close this. Maybe stop computation. I don't know. Okay, something is not right here. Okay, so you know what? Let's go to results. Doesn't like that. Thing is definitely it's got okay. So now select bad. This seems to be a bug here. Okay, so no problem. So let me go ahead and close this. I miserably failed in this. So the question is, how do we get out of it? Let's get out of it. Go back here. Let's kill the physical simulation. We are back to our assembly. Okay, so let's go to our mechanism, motion design. We already have a mechanism, so we're going to use it because it crashed, essentially fell into a loop. Not very good. I ki- killed the job, but the assembly was there, and everything that we have done is there. So there is already. It's not a new one. We're going to use that. Okay. So let's see what we got here. Uh, let's go and check our contact. Let me see what version do I have here. Yeah, 0.1. Very good. Excellent. So now we're going to go and run it. So we go to simulation. This is this is where it fell into an infinite loop. Let's see what happens now. Okay, I can close that. Good. There is no infinite loop. That was a disaster. Okay, so we go to select the results here. This is the dynamic step, and go to results tab, animation, and let's see what happens. Let's play first. This is a friction. Ooh, completely different behavior. You can see. Let's go back here. It comes down. This friction, and eventually it falls off the tip. Now, if I make the friction coefficient 2, okay, and run it again, 0.2, yeah. See what happens. The first time I was not able to close this, now I can. And select the dynamic step, go to results, animation. Let's see what happens now. So let me drag this thing. This is 0.2 coefficient. Yeah, you see, it doesn't fall off the tip. Anyway, you've got to be very careful with what you're doing because you can see that the situation is fairly sensitive to the approach. Now, let me do something here for a second. Let me go here and remember these things that I hit. Let me bring them back to the show mode. Same thing. There's a reason I want to do this. And let's look at the view from the front. And now we're going to go to select this dynamic step, results, animation, and let's see what happened. You see, initially, this is sliding. See that initially, very little rotation. And then when it picks up speed, at some point, it begins to roll. So I just wanted to point out to you that initially there is no rolling involved, or very little. But then gradually the speed builds up, and eventually that rolling condition is met, and things start to roll. I mean, in the nutshell, you got to be careful because there's a lot of physics involved here, which we're not getting into. That's it